So, section 1.4 is dealing with complex numbers. That's when we're taking square roots of negative numbers. They're imaginary. Most important thing, if you have the square root of a negative number, that's equal to I root whatever the positive number is. So if I had the square root of negative 9, that's I root 9. What is the square root of 9? 3. That is 3I. Again, if you have a negative under a square root, it just means you can take that square root and make it an imaginary number, because you can't take the square root of a negative unless it's imaginary.
Does your videos have like audio?
Yes.
They do?
Yes. I squared is a negative 1. I squared is negative 1. Mm-hmm. Oh, why aren't these set up the right way? Sorry. Okay. So looking at number 1, we have 3 plus 7i plus 2 minus 4i. I promise it is not as complicated as it looks. These do not have eyes.
Melvin Chevalier, please report back to biology.
So yeah, you're going to hear that too.
Melvin Chevalier, please report back to biology.
What's
and
3?
Out of the gym.
What's 3 plus 2?
5.
And then these have eyes. What is 7 minus 4?
Wait, 7 minus
3, but it has an eye. That is your answer. Okay.
So wait, can we try this one?
I wouldn't recommend it.
Oh, okay.
Because there's a minus sign. So all I'm going to do is copy down that first part because it does not have a minus sign there. But the things that are after, I am changing those signs. This is going to be a minus 6, and that's going to be a plus 8i.
I'm sick of hearing that drum.
Now, go ahead and see if you can do that.
What did you say about that one? I'm sorry.
You change the signs for the pieces that are after.
Is your number 2 under?
Yeah, for some reason, my number
Okay.
2 is messed up.
That confused me.
Check it. Five and negative 6 makes a negative 1. 9i and 8i make 17i. Okay? When we have questions like number 3, the first thing we want to do is rewrite it using eyes. What I mean by that, we have a square root of a negative number. This can be rewritten as 2 plus, what is the square root of 9?
3.
And it's imaginary
Basante Stone to the office, please. Basante Stone to the office.
because there was a negative under the radical, okay? Minus negative 2 plus. Do the same thing here. There's a negative under the radical, so that means there's an I. And what is the square root of 4?
2.
Here we go. Now, I can do the same thing we did for number 2, now that it looks like number 2. Because these two pieces come after the minus sign, This 2 plus 3i stays the same, but that becomes a plus 2 and a minus 2i. And when I write my i's, I put a little loop on it so it doesn't look like a 1. You don't have to, but I thought it might be helpful. So what do we get when we combine those real parts that don't have i's with it? 4. And then what about the pieces that do have i's?
Negative 1i, or 1i.
Positive 1i. You don't need the 1 there. You could just put plus I. If you put the 1, that's also fine. But that's your final answer for this one. Okay? Now let's get to multiplication. Oh man, this isn't set up the same way again. Sorry. Okay. All right, I'm going to erase that. You're going to tell me what I'm supposed to be writing in here so that it's in the correct setup. For number 5, what does it say?
3 minus, oh wait,
Number 5, sorry.
I don't have 5.
Negative 5. Yeah. Negative 5 minus 9i.
Okay, thank you. And then what about 6?
Square root of negative 2. Square root of negative 8.
All right, thank you so much. Okay, what we did before, did you guys prefer box method for multiplying polynomials? Some of you did. Okay. You can do this the same way. I'll show you what I mean by that if you don't remember what box method was. 3 and then a minus 5i times 2 and a positive 7i. Two times 3?
Wait, 1 second.
Oh.
2 times negative 5i.
Negative 10i.
Good. 7i times 3. I'm going to put a plus 21i just so we know that it's positive. And positive 7i times negative 5i
Negative, or 2i?
times.
Or, oh, okay.
They're negative 35 I
Squared.
squared. Okay. At this point, these two both have just a regular I. So we have 6. We have to combine those two pieces together. So a 21i minus 10i gives us a positive 11i. Are you okay with that step? Yep, okay. And then we have minus 35i to the second. What I like to do, anytime I have an I squared means I change this sign and get rid of the I squared. Because it means I'm taking negative 35 and multiplying it by negative 1. But of all the times that I've tried to show that, people think, oh, negative 35 minus 1, instead of multiplying. So instead of replacing it with a negative 1, I just circle it, and I'm like, okay, I have to change that sign. So now we have 6 plus 11i plus 35, no I squared anymore. Which means I can combine these two like terms. 41 plus 11i is my final answer. Where'd I lose you? No, we're good?
The sign.
Okay,
I started spacing out.
okay.
I was thinking about how freaking annoying Crystal was getting, and I was like, oh my god, I can't just tell her to be quiet. And then I just started going off in my head. And I was
That's
like,
okay.
yeah,
So,
like,
anytime you have an I squared, it means you're multiplying whatever is in front of that I squared times negative 1. So instead of writing it out as every single step, I just take the number in front of I squared and switch the sign once I remove I squared. That's it. So you'll see it again in the next example. So, whoops. All right, so number 5, same idea, but all we have to do is distribute the negative 2i into both. Are we okay with that? Or multiplying? Yes? No? Maybe? So, negative 2i times 5. Negative 10, and it still has an I. Negative 2i times negative 9i, bless you. And again. Plus 18i squared. And at this point, bless you, maybe? I squared tells me flip that sign and get rid of I squared. So I have negative 10i minus 18. Yeah. You could also write it as negative 18 minus 10i. I'm not going to be picky with it when it comes to like your test and stuff. I just don't recall whether or not Delta Math is picky about the order. So, I mean, you'll find out. Just in case, know that they are the same thing. Okay? Questions on that one? Okay. Number 6. We're going to rewrite them using i's first. Almost. This is I and a root 2 because I can't take the square root of 2. And the next one, I root 8. We can break down 8, but we can multiply first. What's I times I? I squared. And what is 2 times 8? And they're both under square roots, which is why I'm allowed to multiply them. What's the square root of 16?
4.
You were so close, yes. 4. But what does the I squared mean? Change that sign. So what is my final answer? Negative 4. Kinda, sorta, maybe. Why do we use an I?
Because imaginary.
Because what?
Imaginary.
Because it's imaginary. I know there's going to be an I whenever I have what under a square root? A negative. Good. All right, let's keep going. Oh, my Lanta. Let's skip 7 and go straight to 8. Are we okay with that? Okay. So, what does it mean when we have an exponent of 2? Same thing twice. Heck yes. Love to see it. Oop. Oh, I got it. Means you write it twice. So negative 2 plus root 3. And negative 2 plus root 3. If you want to do box method for this, that is also totally fine. If you prefer another method, go ahead. I think most people still prefer box method when distributing. Negative 2 and a positive root 3. Negative 2, bless you, and a positive root 3. Negative 2 times negative 2.
4.
Positive 4. Good. Negative 2 times a positive root 3. Think about it kind of like having oil and water. When you have a number that's not with a radical and a number that's under a radical, you can multiply them together, but they don't mix. They just kind of stick next to one another. So this is a negative 2 root 3. Does that kind of make sense? Okay. So then when we have a root 3 times a negative 2, that's also a negative 2 root 3. And root 3 times root 3 is root 9, which equals, not root 3, just 3. So if you have a root times that same root, your answer is the radicand, which is the number under that radical. So if I had root 5 times root 5, your answer is 5. Root 2 million times root 2 million is 2 million. Root metal, it doesn't matter what the thing is under the square root, times root metal is just metal. Okay? All right. So now we can combine like terms. Neither one of those have any radicals, so I can add those together. What do we get? 7. And then those both have root 3, so I can add those numbers that are in front. If I have negative 2 root 3s and I have negative 2 root 3s again, I have negative 4 root 3s. Okay? The only time I can combine roots with addition or subtraction is when it's the exact same root. Okay? That's the gist of that part. Conjugates. Conjugates are fun because they get rid of middle terms. A conjugate means you take the exact same thing, but you change the middle sign. So the conjugate of 2 plus 5i is going to be 2 minus 5i. Let me show you why they're so important. When we multiply these, two times 2, 2 times 5i, 2 times negative 5i. Hey, look, those cancel. One's positive, one's negative. 5i times negative 5i is negative 25i squared, but I squared means change the sign, so that's just 25. If you didn't like that step, here, let me. We would have 4 minus 25i squared, but as we know, I squared means change that sign, so it becomes 4 plus 25, which is 29. We use the conjugate to get rid of any i's. Okay. Can you tell me what the conjugate of number 10 would be? If my original is 1 minus 3i, what is the conjugate? 1 plus 3i. Perfect. And the reason I want to use that is because I don't want any i's in my final answer. Because when I multiply this, I get 1. I get a plus 3i and a minus 3i and a negative 9i squared. Anybody want to see the box and where I got those from? Anybody? Are you sure? Okay. And these two cancel. And I squared means change that sign. So this is just 10. Do you see how it comes back to be a real number? Okay. So when we're dividing complex numbers, all you have to do to rationalize a denominator, multiply numerator and denominator by the conjugate of the denominator. Which of those is a denominator? And I know it seems really silly, but it's a really important distinction.
The bottom.
Bottom. Down denominator. Okay? What is the conjugate of that piece on the bottom? 2 minus I. Perfect. And remember, we can't just randomly multiply a single piece by something. I have to do it to top and bottom. So the top becomes 2 minus I. And we have to multiply out the bottom. 2 times 2 is 4. We would get a negative 2I, then a positive 2I, then a negative 1, I to the second. Talk to me. I see some confused faces.
Can you explain it again?
Absolutely. Our goal when we have i's in a denominator, I don't want it. I don't care if an I is in the top, it cannot be on the bottom. To get rid of it, as we saw in the previous examples, if we multiply by the conjugate, that gets rid of all the i's in the denominator. So when we do that, all we care about is getting rid of the i's down there, and we know that this is how we get rid of them. Because once we're done distributing, we're gonna get a real number down there. Okay? That's the whole idea behind it. So these two pieces in the middle cancel because one's a positive, one's a negative. And this means change the sign, get rid of I squared. So we still have 2 minus I up there, but now we have just 4 plus 1 down below. And what is 4 plus 1? So this is 2 minus I all over 5. Perfectly fine. That's it. Does that help a little bit? Okay. Do I need to stay on this question for a little bit longer? Okay. Now, here's an example of something that will give me a complex solution, meaning it's going to be imaginary. Because there are no other x's or anything else in this, what I can do is get x squared by itself. Subtract 4, subtract 4. X squared equals negative 4. We okay with that step? Bless you.
Thank you.
How do I get rid of x squared? Square root. But remember, when I take a square root of both sides to solve an equation, I need plus or minus. So x equals plus or minus the square root of negative 4. But we've dealt with something like this before. What type of answer is it going to be? Imaginary, because it's the square root of a negative. So x is equal to something I. What is the square root of 4? So x is equal to plus or minus 2i. Just think to yourself every time I'm taking the square root of a negative, it just means I need to put an I in front. Okay? Talk to me. Okay?
Yeah.
Ish?
Yeah.
All right. Let's solve other types of equations. When possible, we want to try to factor. To factor, get one side equal to 0. So what we're going to do is subtract 9x squared. What you have to remember is that if they do not have the exact same exponents, we cannot combine them together. So they just go next to one another. X to the 4th minus 9x squared equals 0. Does anybody remember what to do to factor something like this? We always look for this first. Lena. What were you saying?
I was saying x squared.
X squared is in both of them. Let's take that out because they have that in common. When I take out 2 of those x's, what's left in the first one? How many x's? 2. So this is x squared. And if I take away 2 of those x's in the second part, I'm just left with -9. So that equals 0. Right? Okay. This is one of those special factoring patterns. Does anybody remember what that is?
James will want to pay to the office, please. James will want to pay to the office.
No. Say what you were saying, please.
Is it the one where you have to put the x in front? Or is it the one where you have to add and multiply?
Okay, this is going to add to 0, multiply to -3. Because there's no middle term, it means we're still going to have that x squared outside. One's going to be plus, one's going to be minus. X plus what and x minus what? 3. Because 3 times 3 is 9, and -3 times a +3 is -9, and -3 plus 3 is 0. Does anybody remember the word for when it's the exact same thing but different signs? Starts with a C.
Coefficient? Oh.
C-O. C-O-N. C-O-N-J.
Conjugate.
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 It doesn't just have to be imaginary stuff. I know, it's okay. I'm not judging, I promise. At least not right now.
Save Santa Claus to the front.
Once you
office,
get to this
please.
point, you can set each piece equal to 0. You know that x squared is going to be 0, x plus 3 is going to equal 0, and so is x minus 3. So what are my possible answers for x? That one is hopefully easy. 0. 3 is one of them. And? How do I get x by itself there?
X. 1. I don't know.
Minus 3. Hi. Just teaching, you know. Kinda. I'm gonna pause my YouTube video thing. You are more than welcome to stay while I continue to record stuff and go over stuff.